Hi, finally the final video in electrical energy, paying for electrical energy. When you're ready. Okay, so electrical companies charge you in units, and these units are called kilowatt hours, and what they represent is the amount of energy converted by a 1 kilowatt appliance in 1 hour. Now, if energy companies were run by physicists, we would just charge you in joules, how many joules you use, because that's what you're actually using. You're using energy, and energy is measured in joules. But because they've decided to use this kilowatt hour, it all gets a little bit confusing. So we'll just work you through a couple of examples, and that's basically all you need to know to work out the cost of electrical power, or examples that we use. So let's do a couple here. Now this is again from an English book, and they're saying it's costing 8 pence per unit. So that's 8p per kilowatt hour. Now in Australia, I was just looking at my electricity bill, and it's 25 cents per kilowatt hour. So we can factor that in when we do these calculations. So let's do an example. Here we have a 2 kilowatt bar heater, and we're going to run it for 6 hours. So the energy used is 2 kilowatts times by 6 hours. Now this is probably the only time in our physics questions where we don't use standard units, and so we've just got to remember to keep it in hours, because we want to end up with the unit kilowatt hours. So it's 2 kilowatts times by 6 hours gives you 12 kilowatts, and so the cost in this case is 12 times the cost of the electricity. What's 12 times 25 cents would be $3. Now remember, so if I was to do this, let's just see, this would be in Australia, this is 12 times 25 cents, and so our answer, if we put that into the calculator, it would be 300. Now a lot of students like to just think, oh, that's $300. Whew, your parents wouldn't be very happy about that, but it's actually $3, okay, because you've worked out your answers in cents. So this is just a little trap for young players. So let's do another one. 100 watt light globe is left on for 9 hours. So we convert the 100 watts into kilowatts. So here we were given kilowatts. Here we have to convert it. So 100 watts in terms of kilowatts is 0.1 of a kilowatt. Yeah, because there's 1,000 watts in a kilowatt. And 9 hours, we get 0.9 of a kilowatt hours, and we times that by the charge involved. Okay, when you're ready. So when we did the example of the bar heater in the last video, we got lots and lots of joules, and this is just saying that and that was only for a couple of hours. So most electricity bills are quarterly, so every 3 months, and so you'd end up with a massive number of joules being used. But this is arguing that that's too clumsy, and therefore it's much better to use the units that the electrical company is using, which is kilowatts or kilowatt hours, more precisely. It's just something you just have to get your head around, I think. So the number of units, where the units are kilowatt hours, is the kilowatts times the time in hours. So let's do an example. That's probably the best way to end lots of confusion. So here we have a colour TV drawing 2.5 amps. It's connected to 240 volts. What is the power rating? How much energy is used if it's operated for 5 hours a day for 4 weeks? And what is the cost of running, where it's charged at 11.87 cents per kilowatt hour? So first one is just using P equals VI. You get 600 watts. Okay, and so the energy equals the power times the time, and so we get 28. The time is 28 days at 5 hours per day, so 140 hours. And the power, we need to convert so the time has to be in hours. Yep. and the power has to be in kilowatts, so we've got 600 watts, which is equal to 0.6 kilowatts, and so the energy equals the number of kilowatts times by the time in hours, and so in this case it's 84 kilowatt hours. Okay, follow that. And then the cost is this, the kilowatt hours times by the rate, and that's 11.87 cents, or 997 cents. Okay, not dollars, because we're working it out in cents, or $9.97. But recognizing that the current rate is twice that, it's actually $20 more or else if we were to do that calculation today. So you're going to have these questions sitting on your OneNote for you to do, just to get an idea of how to do these questions. Once you get them, they're pretty straightforward. Just got to look out for those little traps. And they're the answers, and they'll also appear on the OneNote. Some other things for you to do. There's going to be a little Java thing on the OneNote for you to do, how to make circuits, another Java thing. There'll be a video on touching an electric fence, and there'll also be a video on police using what are called tasers. Most of us should have heard what tasers are. Tasers are things that are designed to shock people, so it's supposed to be a non-lethal weapon. You fire it at makes them convulse because it puts electric current through them. Now the trouble with current tasers is they don't have much of a range, only a few meters, and so people have now designed a taser that can be fired from a shotgun, and it comes out as this own individual capsule. It's like a flying taser, and so there's no wires or anything that link the police officer to the taser either, and so you've got a much greater range, this time from 5 to 20 meters. And there's going to be a video on YouTube from a TV program called Future Weapons showing you about that, which is fairly new actually. And we'll also be able to do an experiment later on about blowing a fuse and how fuses work. So that's it for electrical energy. Hope you followed it all, and we'll move on to the next topic. See ya.